All right then, welcome to my video. So now here on this video, we're going to discuss an introduction to calculus. Now calculus has four main components. We have the limits, we have the differential calculus, which is the differentiation, we have the integral calculus, which is the integration, we have the multivariable calculus, which is function theory. So now the calculus that I'm going to dwell onto for this semester, it is a differential calculus, which is called the differentiation. But before we start with the differential calculus, on this video as an introduction, I'm going to discuss with you the cubic function, okay? So we're gonna talk about the cubic function, okay? So now, focusing on the cubic function, I'm going to dwell on most important things for this curriculum. I'm not gonna dwell too much on the factor theorem, the remainder theorem. I'm just gonna shoot straight on how to calculate the factors of a cubic function. Now, before we can even discuss the cubic functions, we have learned that there are many different types of functions. We have learned there are linear functions, exponential, parabolic function, as well as hyperbolic function. Now, a cubic function, it is a special type of a function that focuses on calculus, okay? So now, a cubic function, the highest degree or the highest exponent of a cubic function is most definitely 3. Let me just show you an expression of a cubic. Let me show you the cubic expression, not the cubic function. Remember, function, it is the equation, but expression, it is an expression without the equal sign. So let me show you the cubic expression, okay? So the cubic expression is something that looks like this. A to the power of x to the power of, ax to the power of ax to the power of 3 plus bx to the power of 2 plus cx plus d. Now, this expression, we call it a cubic expression, whereby its highest degree is equals to 3. So that means the moment when you see our variable to be x and it has the highest degree of 3, therefore the expression will be regarded as a cubic expression. So immediately when we include the equal sign, where we're going to say y is equals to this expression, now we are talking about the cubic function, where now we have included an equal sign. So what you see here on this board, what you see, it is the cubic function, okay? So now the cubic function, in exam, this is what you need to understand when it comes to the cubic function. Like I said, I'm going to just touch up on the bits of cubic functions that are highly needed from you to understand. So now, this is a cubic function. In exam, you can be examined to draw a cubic graph, okay? So that means you need to be able to know how to draw a cubic graph if you are provided with a cubic function like this function over here. And at the very same time, you need to know how to determine the equation when you are given a cubic graph on your Cartesian plane. Say, for instance, you have a Cartesian plane just like this, okay? Say, for instance, you have a Cartesian plane just like this. Now, when you have a Cartesian plane just like this, and then let's draw our cubic function on this Cartesian plane. Now, this graph that you see over here, so remember here we have y-axis, and then here we have the x-axis. Remember, this will be our Cartesian plane. And on this Cartesian plane, I have a function. Now, what is the name of this function? It is called the cubic function. Now, how do you know, or how would you be able to see that this is a cubic function? Cubic function, it has two turning points, okay? It has two turning points, or you can also call these turning points the we have the local minimum point, and then maximum, we have the maximum. We have, oh, let's start with this. We can call them the stationary points, okay? So there are two stationary points of a cubic function, or two turning points of a cubic function. This turning point, or this stationary point, is called maximum local point. And then this, it is called the minimum local point of our cubic function, okay? So now you need to be able to know how to, from this graph, be able to know how to determine the equation. If you are provided the equation, know how to draw the graph. Now, okay, now this is what is happening. Again, the cubic function has 3 x-intercepts, okay? We have x1, and then we have x2, and then we have x3, okay? These are 3 x-intercepts of this cubic function. Say, for an example, you are given the equation in this form. and they say to you, from the equation provided to you, determine the what? Determine the x-intercepts of this cubic function. Now, meaning in this case, they want you to determine the x values whereby y is equals to 0. So we know that the x-intercepts, we let our y, numerical y value to be equals to 0. So meaning if I were to determine the coordinates of this point, I know here my x, it's x1, my y, it's 0, okay? Same applies to here, my turning point, not my turning point, my point on x2, it's going to be x2 is to 0. And then at this point, it's going to be x3 is to 0, okay? So that means our numerical value of y is equals to 0. So that means if we are given equation like this, we're going to set our numerical value of y to be equals to 0, and therefore most definitely we're going to have to factorize this expression over here to determine the factors that we are going to equate to 0. And therefore after determining these factors that are determined, we're going to have 3 factors, okay, because it's a cubic function. After determining these factors, now these x values will be representing our x-intercepts. But now here's the thing. This is what I want to do on this video, okay? It's highly complicated to determine the factors of a cubic function just like this. Remember, when you want to determine the factors, you need to employ what we call the factorization. But it's not that easy. Sometimes it's not that easy to factorize a cubic function that looks like this, okay? Remember, how do we factorize an expression? We take out the common factor, and that's it. But in this case, say for an example, you cannot take out the common factor on this cubic function. And therefore, what are you going to do? Therefore, there is this method that we call grouping, okay? There is this method that we call grouping. Grouping is one of the methods that we can also utilize to determine the factors of this expression. Say maybe you group this term to this term, you group this term to that term, and then you want to take out the common factor. Now it happens that again, it's highly impossible for you to apply grouping when you want to factorize this. Therefore, what are you going to do? There is another method once more again for cubic function, which I'm going to do today, okay? So remember, you're just gonna do your linear factorization. If linear factorization fails, you do what? Your grouping factorization method. If factorization, the grouping factorization method fails, then what are you going to do? There are 2 methods now. We call them the long, we have the long division method, or you can also use the synthetic table method, okay? So I don't want to dwell too much on that for now, okay? So now, say, let us do an example, okay, whereby we are given the cubic function, okay? Now, let us do this example. Say number 1, you are given a cubic expression, okay? It's a polynomial. So let's say we have x to the power of 3 plus 5x to the power of 2 minus 4x subtract 20, okay? Now, this, it is a polynomial function or a cubic function because its highest degree is 3. Now, statement here says to us factorize the following polynomial, okay? Now, this is a polynomial. Remember, this is a cubic function, but now how are we going to factorize this? This is one of the reasons. Why am I showing you how to factorize? It's because during the semester, like I said, here I'm just going to focus only on cubic function. During the semester, you'll be given a cubic function in a form of graph, and they say to you, determine the x-intercepts. So I'm saying to you, in order for you to determine the x-intercept, you're going to have to be able to know how to factorize this. You understand what I'm saying? So there is these 2 complicated methods that I'm going to employ. So the other methods you guys are familiar with, but for one of the reasons, this is why I'm doing this video, is just that I want to show you on how to factorize this using the synthetic table method and the long division method, okay? But now let us start with this expression first, okay? Remember, when you want to factorize, you're going to take out the common factor. Is x common in x cubed? Yes, x, it is common. X, it is common, but here we do not have x at all. So that means I cannot do linear factorization to factorize this cubic function. Even if I consider any number, there is no number that is common out of all of these 4 terms. That means linear factorization fails. And therefore, what is the method that I can use to factorize this grouping, okay? So now let us try to group these two terms first to see if there will be a solution. So I'm going to group x to the power of 3 plus 5x to the power of 2, and then close my bracket, and therefore I'm going to take out a negative out as a common factor, and then here I'm going to have 4x. Remember, I took negative out as a common factor. I have plus 20 in this bracket. Now, let me try to factorize this to see if this bracket will correspond with this bracket after factorizing. Now, what is the common factor in this? It's x squared. So that means I'm going to take x to the power of 2 out of the bracket. And then here I left with x. And then here I left with 5. And therefore, here I'm going to take 4 as a common factor. Remember, I have negative over there. I take 4 out as a common factor, and then here I left with x, and therefore 4 goes how many times into 20? It goes 5 times. Now, this bracket corresponds with this bracket. Therefore, what am I going to do? This is an expression, right? So that means what is common? Remember, this is common, x plus 5, x plus 5. It is common in this expression. So I'm going to take x plus 5 as a common factor out of this expression, and therefore here after taking x plus 5 I left with x to the power of 2, and then here after taking x plus 5 I left with negative 4. Now remember, I said to you cubic function has what? Has 3 factors, okay? So that means here I have x plus 5, and then let me factorize this. I can see over this, it's a difference of 2 squares. So that means I'm going to factorize this further by opening up 2 brackets. What are the factors of x squared? It's x and x. What are factors of 4? It's going to be 2 and 2, and therefore the other bracket is going to be negative, the other bracket is going to be positive, and therefore voila, this is how we factorize a cubic function, okay? So this is the simplest way to do it, okay? Remember, the method that I used here is what? It's grouping, okay? It's grouping. I did grouping method to factorize this expression over here. But if grouping failed to perform what I did right here, I was gonna consider another method, which I consider to be one of the most different method that maybe you've never came across into, since when you are maybe new to calculus, okay? So this is the first way to factorize a cubic function. Now, another example, they say to us, we have x to the power of 3 plus 6x squared minus 7x subtract 60. Now, how to factorize this expression? Remember, is there any number that is common out of this expression? No, nothing is common that I can take out as a common factor. And therefore, I'm going to consider the grouping. If maybe I want to group this and that, and I want to group this and this, I'm not going to get the same result as I factorize these 2 terms and these 2 terms. So that means here you can tell that grouping it is most definitely going to fail. Aha. Therefore, what am I going to do to factorize this cubic function? Therefore, there is what we call remainder theorem. Okay, like I said, I didn't start with it because I think that's unnecessary and it's gonna take a lot of time. For this curriculum, I'll show you how to do remainder theorem through this example. Okay, so now this is what you're going to do. Okay, remember we want to determine the factors. Okay, we want to determine the factors of this expression. Okay, so now how are we going to do that? Assume that this expression is a cubic function whereby it is given by y is equals to this expression, okay? So now if I want to determine the factors, I'm going to determine my x-intercepts of this factor, of this expression, okay? Remember, the factors are the x-intercepts of this expression. Equation. Now, this is what I'm going to do. I'm going to use the remainder theorem, whereby I want to let my y to be equals to 0. Now, how am I going to factorize this? Now, this is simple. You take your calculator. You're going to substitute the integers. You can start from 1, positive 2, positive 3, positive 4. Or you can start from negative 1 to negative 2 to negative 3 to negative 4 until you get 0. Now, this is what we are going to do. On this expression, we are going to substitute positive 1. I choose to start with positive 1. If I substitute positive 1 over here, I substitute positive 1 over here. I substitute positive 1 over here. On my calculator, this will give me negative 60, right? Okay, that's fair enough because I was supposed to get 0, but I got negative 60. Now I move because I see that 1, it is not giving what I want this expression to give me. So that means I'm going to substitute positive 2. I move from 1, now I go to 2. I'm going to substitute positive 2 over here, positive 2 over here, and positive 2 over here. Now, when I punch the whole expression after substituting positive 2 onto this equation, I'm going to get negative 42. Now what I see is that I am moving towards 0. At first, when I substituted 1, I got negative 60. Second time, when I substituted 2, I got negative 42. So I see that I'm moving towards 0. Now, okay, I'll consider substituting positive 3 so that positive 3 can take me maybe close to 0, or it can even take me to 0. So now I'm going to substitute positive 3 over here. I'm going to substitute positive 3 over here. I'm going to substitute positive 3 over here. After doing that, the whole expression now will give me 0 when x is equals to positive 3. Aha! For a fact that when I substituted my 3 over here, I got 0, that means for this expression, I have only one factor, which is this one. Let me show you. That means x, I'm going to say minus 3 because I remember x is equal to 3, but when I take 3 to the other side of the equation, it's going to be negative 3. So hence why here I say it's x minus 3. So that means x minus 3 is a factor of this expression, since, well, when I substitute my positive 3 over here, I got 0. So that means I'm going to deal with this factor to determine other remaining factors of this expression. But remember, this is a cubic function. That means how many factors do I need? I need 3 factors. Already, I have only one factor. You cannot just substitute all of the values until you get 0. No. So that means this is the remainder theorem, okay, whereby our remainder was 0 in this case. There was no remainder because we got 0 by using this factor whereby x minus 3 satisfies this equation to be equals to 0. So now this is what I'm going to do. I'm going to use it's either to factorize this. I'm going to use long division method, or I'm going to use a synthetic table method. So I'm going to show you 2 methods, but I'm going to start with long division method first, okay? So long division method. Right. So if I consider to use long division method, remember, this is my factor. I'm going to say here I have x minus 3. And therefore, this cubic function over here, I'm going to write it under this line. So I have x to the power of 3 plus 6x to the power of 2 minus 7x minus 60. Okay, so this is our cubic function. So now let us divide this cubic function by this factor to get other factors. So now, so how am I going to treat this? So I'm going to take the first term, okay, which is x to the power of 3. So I'm going to divide it with this x. So I'm going to say x to the power of 3 divide by x is going to be x to the power of 2, right? So that means I'm going to write this variable over here, x to the power of 2. And then after dividing x to the power of 3 by x, I'm going to write my answer over here, which is x to the power of 2. And therefore, this x to the power of 2 multiplied by x, I'm going to get x to the power of 3, and I'm going to write it over here. X to the power of 2 multiplied by negative 3x is going to be negative 3x squared. And therefore, I draw up a line over here. Now I am going to add moving downwards. So, but before I add, I need to make sure that this I multiplied by negative. So that means the whole thing I'm going to multiply by negative. So when I multiply the whole thing by negative, here it's going to be negative, and there's going to be positive. Therefore, this plus this is going to be 0. Therefore, what is 6 plus 3? It's most definitely 9x squared. And therefore, I take these remaining terms, I move down with them, 7x minus 60. And then I repeat the same process that I started with. I'm going to say 9x squared divide by x is going to be positive 9x. Positive 9x multiply by x is going to be 9x squared. And therefore, positive 9x multiplied by negative 3, it's going to be negative 27x. Therefore, I draw up a line once more again. Remember, moving downwards, I add. But before I add, I multiply the whole thing by negative. So that means here we're going to have negative, and then there we're going to have positive. Therefore, this plus this is 0, and then negative 7x plus 27x is positive 20x. And then I move down with negative 60 over here. And then I repeat the very same process once more again. I'm going to say 20x divide by x. It's 20. I write my answer over here. And then I multiply once more again. 20 multiplied by x, it's 20x. And therefore, 20 multiplied by 3 is going to be negative 60, right? Therefore, I'm going to add moving downwards. Do not forget that. So, but before I add, I multiply this by negative. And therefore, negative 20x plus this is going to be 0. This and this is also going to be 0. So that means there is no remainder over here. So now I go back to my solution. So this, remember, it is a factor, and this, it is also a factor for this cubic expression. So that means I'm going to say, okay, let me write it over here. I'm going to say x minus 3 multiplied by x squared plus 9x plus 20 plus 9x plus 20, okay? So now let us factorize this further. So that means you have x minus 3, and then I'm going to open up two brackets because this is a quadratic expression. It's no longer a cubic expression. So that means I'm going to open up two brackets. And then what are the factors of x squared? Is going to be x. And then what are the factors of 20 that will yield to 9? It's 5 and 4, right? It's 5 and 4. And therefore, here is going to be positive, positive. And therefore, these are the factors for this expression. How did we determine these factors of this expression? We used the long division method, but first we determined the factor before we could use the long division method. So I'm saying to you, the long division method, you might find it much more complicated, but there is another method that you can use instead of using a long division method to determine the very same factors. So now let's consider another method, which is called the synthetic table method, okay? Using the very same example. So remember here we have x squared, x cubed plus 6x squared minus 7x minus 60. So remember, we have already determined that x minus 3 is a factor. Okay, we have already determined this, and I told you how to determine the factor. Substitute your numerical values until you get 0. Now, if we want to use a synthetic table method, it is still fine if you do not want to use the long division method. So now, when you do your synthetic table method, okay, so we're going to take the coefficients of our expression. The coefficient of x to the power of 3 is 1. I'm going to write it over here. The coefficient of x squared is positive 6. I'm write it over here. The coefficient of 7 is negative 7. The coefficient of x is negative 7. I'm writing it over here. And this is a constant, which is negative 60. I'm going to write it over there. Therefore, when I use this method, okay, let me just extend here, here, and here, and there. Say we use a synthetic table method to determine the factors of this expression. So we have already indicated that x minus 3, it is a factor of this expression. So this is negative 3, right? But when I write it over here, it's going to be positive 3. Remember that. So now here will always be 0. And then here, supposed to be 0. Here will always be 0. Here supposed to be 0. So that means moving down the table, I add, okay? So I'm going to say 1 plus 0. It's 1. 1 multiply by 3. Now I move diagonal, I multiply. When I move down the table, I add. When I move diagonally, I multiply. So 1 multiplied by 3, it's 3. Now I move down because I want to figure this value over here. So what am I going to do? I'm going to say 6 plus 3 is going to be 9. Now I want to figure this value diagonally. I multiply. 9 multiplied by 3 is 27. And therefore, negative 7 plus, remember, I move downwards, I add. Negative 7 plus 27 is going to be positive 20. Then positive 20 multiplied by my factor is positive 60. Sorry, or this 0 is supposed to be here. And therefore, negative 60 plus 60 is 0. Can you see that? And therefore, that means here, I'm going to formulate my cubic expression. So here I have x to the power of 2, and then here I have x, and then here I have a constant. So that means the factors of this cubic function is going to be, remember, x minus 3, and therefore I'm going to take this to be my coefficients of my x values. So that means I have x squared, which is 1x squared, 9x, plus this constant, which is positive 20. Therefore, let's factorize this expression further. So I have x minus 3, and then I open up 2 brackets to factorize this quadratic function expression. And therefore, here I have factors of x squared. It's going to be x, and x factors of 20 is going to be 5 and 4. Positive, positive, that means positive, positive. And therefore, voila, we got the factors using the synthetic table method instead of long division method. So that means it's either you go for synthetic table method, or you go for your long division method. Okay, that's how we solve this equation.